Hello everyone and welcome to this video. This video is part of our ShadowMe project, which is a series of videos and labs shadowing a digital forensic investigator or a malware analyst. My name is Ali Hadi and I will be your instructor for this video. So we decided to start our series with malware analysis. So this is our first video of a series of videos related to digital forensics and incident response and malware analysis. So we created this malware sample, and the first thing usually what you do when you want to start doing a malware, when you start doing malware analysis, is really doing some reconnaissance on the file sample itself, and that is by looking at the file headers, the structure of the file, all of the, let's say, libraries which are being used by the file, the strings, the functions, the headers, again, all of these details which you can pull a lot of info out of the sample by just checking those and without the need to run the sample itself. So this is, let's say, our step one before maybe running the sample or before, let's say, reverse engineering it or debugging it or whatever. So once you download the file which has been the sample which has been created for you for this lab, all you need to do, because we are using a Flare VM, it's already configured in a way for malware analysis. So if you right click and then unzip with the password infected, it's going to unzip the file for you. And as you can see here, why do this .bin? So we kind of have the .bin file extension just to make sure that maybe, let's say, someone by mistake double clicks on it and runs the sample on their system. So this way we can kind of protect ourselves from doing anything wrong to the system, so, or our system. So what we will do now is we're going to go over a set of different tools and analyze this sample, look at the strings, look at the headers, look at the different data which we can pull from this sample by really just investigating the sample excuse me, itself. And we'll use different tools in order to do that. There are lots of great tools out there, so we are going to be covering a couple of them in this video, and then in future videos we'll reuse them again or we'll add others as we see necessary. But at the end, the goal, you can use whatever tool you want. The goal is really not the tool, but more of to learn on what should we look for and what is important information to us, etc. So let's start by right-clicking on the file and going to Detect It Easy. So we can load the sample in Detect It Easy, as you can see here. And it was, let me close this. And we can see that it's telling us that it has been compiled, or the compiler is Visual Studio, Microsoft Visual Studio 2019. Now, Detect It Easy has some capabilities or ways of understanding what is the compiler, what's the linker that has been used to create this executable, etc. We can also see that it's a 64-bit application or a 64-bit executable. We can see that it is like created to target an AMD 64 or a 64-bit system. So the architecture of the system that this is targeting is going to be an AMD 64. We can see it's a type of the application is a console. We can see the file size, and we can see these by really just looking at this is the main window. Now, if we click on the advanced, now we get a lot of other details or a lot of other, let's say, buttons, and each one of these buttons will really take us to more information about the sample. We'll try to kind of go over the most important parts. We won't cover every single piece, but please, at the end, use the tool or use any other tool of your choice to kind of investigate the sample. So if we kind of, let's go for file info, if we click on that, we can see part of the info that is pulled is telling us where the file is located, the size, the operating system, Windows or Windows Vista, the architecture, the mode 64-bit. It's a console, and it's telling us it's using the Indianness is Little Indian, and so on and so forth. If we go to hash, we can see the hashes for the file. So we can see the different hash values. These have all been calculated for you automatically. If we go to the entropy, we can see the entropy of the file. So it's kind of telling us that this sample is probably packed. Now we can't really, let's say, take this and use it as yet this is 100% packed. This is kind of telling us it might be packed, so I wouldn't use this as a definitive answer that the file is packed, but it is a good indicator. We can go to the entry point, which will give us the address for the entry point of where the execution will actually start. Many people think the execution actually starts at main, but the execution starts somewhere else. We'll see that in other videos. So this is really telling us that. If we go to the image DOS headers, it will give us these details, and these we can see them in other ways. We'll see them in a little bit. If we go to the NT headers, we can see this is the NT headers and how they look like, especially like when we list them in this info window. We can also kind of from here decide that I want my output to be, let's say, in JSON format. So you can see this is now in JSON format, and if you want to save it, you can go ahead and save it. If you want to get the output in, let's say, XML format, so it's all like tag based, so we can see we have these tags, and I can also save that. It might be useful for you for whatever purpose, but this is just a way kind of to display the information in another kind of format. So it's really up to you what you want. Now, if we go, for example, to strings, this is one of the important things that you will need to do when kind of investigating a malware. So looking at the strings, so we can kind of like at the beginning maybe scroll through them. We can see the default size is 5. We'll see if we want to increase that. We can also kind of sometimes search for strings, so maybe like DLL. We can see if we search for the word DLL, then we can see these strings come up, and these are probably the libraries which are being referenced by the executable itself. So we can see that. Maybe if we search for, let's say, reg, or like some registry, or like an IP address, or like www, sometimes if you are looking for web access or whatever, so we can really see any of that. If we, let's say, for exe, so if we did .exe, we can see that these are 3 strings that show up in the output. Luls.exe, which is kind of weird. Why do we have that word in there? So that's probably an indicator to document, so I would document that. We can see also C Windows Notepad.exe. Probably later on we'll find out why are these in there, and so on and so forth. So really what you can do is do the different filters. Now, why did I choose those? I chose those. Definitely I know what the sample is. That's 1, and 2. You'll be using different keywords, so it's really up to you. But at the end, what you will need to do is kind of try to scroll through the content and see what kind of strings that you might find in here and that are useful to you in your analysis. Like, so if I, as you can see here, if I scroll quickly, I can use page up and page down. There are some weird strings over there. We can see these are the probably the Windows APIs which are being referenced in the executable. We can see all of that. We can see, by the way, also the offset. So where is this located within the exe itself? We can see the type of this string. So as you can see here, A is for ASCII, and if we put Unicode's already there. So I think if we, let's see if we can find other strings in here. As you can see, these are all of the strings that we can find. We can even filter them or sort them by type. So as you can see here, these are the Unicode strings, and that's why we see them over here. And then, so now we got to the bottom. Let me scroll a little bit up and see if we can find anything else that might be useful. Let me maybe remove this and this, so kind of have less. Again, this is it's really a trial and error, so it doesn't mean that you might find things from the first time. You might need to spend some time on this So it will take time, but at the end, you'll need to kind of check that. We can see some weird strings over here. By the way, what are they? We have no idea yet. At least until now, we can kind of assume that there is something. We can see a lot of weird strings in here. So probably there is some obfuscation going on. What is it? We don't have an idea currently of what that is, but this is a lot of different weird things that we can see in here. I'm using page up on the keyboard, so if you kind of see that these are going up fast, that's what I'm doing over here. Again, I'm trying to skim through the sample and try to pull as much information as I can just by skimming through this. Okay, now another thing what you could probably do is increase the string size. So instead of looking for 5, maybe look for 8 and do search again. So now we are looking for any string that is 8 characters or more. So as you can see, these are 8 characters or more. We no longer find shorter characters, shorter string, sorry, in the output here that we are seeing here. And again, we can see a lot of different weird stuff over there. We can see this string over here, which is kind of weird, but it's probably, by the way, we can read it, and we'll see another tool might help us decode this easily. We can see this is another weird string. This is another weird string. These are all going to be, by the way, useful for us to document. So we can see also the Wireshark is being listed here, Process Hacker, Explorer, and so on and so forth. So just by looking, by the way, at these strings, we can still pull a lot of information from them. We can see all of this, and you should document that down and use it for your benefit moving forward with your investigation. So let's close this for now. We have kind of have an idea what's going on through the strings. Let's look at something else. So you can use VirusTotal kind of to check with VirusTotal. We can do a search if we want to search for something like strings. As you can see here, if we want to do some searching for strings, hashes will give us the hashes for each section. Okay, so we can see the hashes for each section that we have, the MD5. If you want to change that, it will give you the hashes for the whole executable and the specific section. We can see the entropy. If we go there, that's where it's telling us that it's packed, and it's kind of, this is again based on what the tool is seeing in the file itself. So as you can see here, the header, the PE header is not packed, so that's the entropy is very low, 3.09, which is very low. Everything which goes towards 8, which is, or 7.9 plus plus, that's going to be a high ratio, which kind of could be seen as obfuscated or packed. As you can see here, we can see each section alone. So you can, and then when you click on that, it will highlight, PE Studio will highlight the like the section for you if you navigate down. If we look at the packed one, so if we kind of click on this, we can see over here the data detected keys is assuming that this is packed, probably because the data in here is kind of gibberish or obfuscated. But again, it doesn't have to be packed, or it doesn't have to be like a definitive answer that, yeah, this is packed, whatever. This is kind of good indicator, but it's not one only indicator. If we had extractor, anything in here, we could have seen that. We'll do that for later in another like video or in another sample. We can see that we have 7 sections. We'll come to those in a little bit. We can see the timestamp of when this application has been compiled. So as you can see, it has been compiled. At least that's pulled from the executable itself. And then, and by the way, this could be modified easily or stripped out, whatever. We can see the size of the image itself is the size we can see over here. We already talked about these. So let's go ahead and look at the import. So if we click on the imports, it's going to open this new window, which talks about the imports that we have within this executable. Now, we won't go into very complicated details in this video. We'll gradually get there when we move on within our series. But for now, we can see that these are all of the libraries which are being imported by this executable. And what that means, it means that this executable might be using one API or one function from this library or more. So that's why it's probably showing up in here. So as you can see here, when we go to kernel32.dll, when you just click on it, we can see these are all of the functions or the APIs that are being referenced by this this executable. Now, does this execute, or let's say, does this kernel32.dll only have these APIs? The answer is no. These are only the ones that are being referenced by this executable. If we go to user32, we can see it's only one. And again, user32 has a lot of APIs, but we can only see one because that's probably the only one being used in here. If we go to shell32, we can also see one, and this is shell execute. We'll talk about like the importance of these later when we use another tool. For now, let's just look at them and what they are, etc. If we go to win inet DLL, we can see these are this is the DLL and these are the functions, and they are all to deal with like the internet. And then over here we can see we have this URL download to file, so it's probably being used to download some file from the internet. So as you can see here, Detect It Easy was able to kind of give you all of that. And by the way, as you can see, there is a lot that you can do with Detect It Easy. This was just, and I'm just going over very basic things, very basic stuff for now, but these are all the same things. And I want you also not to kind of just navigate it from there. These are the buttons that if you click on entropy, it will take you to the entropy page. If you click on strings, it will take you to the strings page. But if you also go, for example, to PE, it will give you this. And then as you can see over here, this is same thing, just now in one single page, and then you can navigate the way you want. So it's really up to you how you want to navigate through this, and so on and so forth. So if we go to resources, for example, we can see that this executable only has one resource here, which is the manifest. And we can see in the manifest over here, this text, which is, if we go to strings, we can read the strings in a little bit more fancier way than looking at them in hexadecimal and trying to read them over here. It's really up to you the way you want to look at this. And again, there's other tools which can help you with that. If we go to PE, this will kind of give you the full details of the portable executable, like the machine, where that machine was the data where we saw the machine is AMD 64, which is telling you the architecture of the system that or the system that is being targeted or this application compiled for. We can see over here the number of sections. So we are looking, by the way, now at the header, but we are looking at the file header. Okay, and then we can see we have 7 sections. So we'll go there in a little bit and check that out. We can see the timestamp. So this is the timestamp, and this is being converted. So that's where this timestamp is really pulled from this value, which is an epoch time. Another important thing probably here is the characteristics, which are the flags over here. And we can see if you click on this, which will show you what are the flags which are available. So anytime you click on one of these, so for example, just let's just do this. If we click, can we set it up? Okay, we'll see how to set that up, no problem. But anytime you click on this, by the way, okay, this will change the value in there, and like currently we can see that this is an executable, so that's why this flag is being selected, and then this one is a large address aware, so it's telling you that this executable can deal with memory address which is more than 2 GB. We'll see that in a different tool as well. So these are the flags which are available. If we go to like the optional header, we can see the magic value over here, and it's telling you what is the magic value. We can see the linker, the loader, size of code, all of these details. The entry point, which we saw previously, It's telling us this is the entry point, and it's telling you that the entry point is located in the .text section. We can see all of that. And if we navigate or scroll down, we can see a lot of other things. Like the subsystem is telling us it's a Windows CU, which is the console. And there are other flags. Again, if you open this, it will tell you this has a high entropy, dynamic base. We'll talk about all of this, like ASLR and NX compat. We'll talk about those in another video, but not for now. But these are the different flags that this might be set with. Okay, these are all being pulled by Detect It Easy. Again, if you go here, we can see all of the directories that we have. So we have the export directory 0, means we do not have an export directory, and that's probably because we are dealing with an executable and it's not, let's say, exporting anything, but we do have our import directory and so on and so forth. So we can see all of this, by the way, just by looking in Detect It Easy. Again, this was the import that we saw previously, and so on and so forth. So let's go ahead and look at another tool, examine this executable, but by looking at it in another tool. Again, please spend some time, look at this, check it out. There's a lot of great features in there. This was not a video to showcase more about the tool, but try to show at least a little bit about the tool, and as well as what we are looking for, etc. So we'll keep using different tools for checking out how good these are. Let's go ahead and look at another tool over here. So if we can see, let's see, which tool am I going to use? CFF Explorer is, by the way, one of my favorite, but I'm not going to use that in this video. I want to use something else. So let's see, tools, and then PE, and then PE Bear. This is another great tool, by the way. Did it start? Yeah. Okay. So all we need to do again now is drag and drop, probably, which is as easy as that. And then this tool again is another great tool to examine and look at file headers, strings, etc. We can see as you click on these, by the way, you can see it kind of shows you that area within the executable itself, and it also is showing you down here the disassembly behind that code. So as you can see here at the beginning, we can see the MZ and then the code over there. When we go to the DOS stop, we can see this program cannot run in DOS mode, etc. And then again, the disassembly over here. So you can navigate if you want to navigate through the disassembly like that. It's really up to you. But we can also go to these tabs over here and look at the content. So we can see here the path, we can see the size, we can see the file alignment. We'll talk about that in the future. The import hash, which is a hash value for the import table or the import directory, the checksum, the MD5. These are the hashes which we saw previously. If we go to strings, similar to what we saw before, we can see these are all the strings again that is pulled there. We can do again, let's say, search for strings, so we can look for those exes that we saw over in Detect It Easy. We can see that. So you can search for the strings as well in here, and you can see the type is ASCII, the length, you can sort by them. So you can sort by, maybe you can't sort by this, or maybe I'm mistaken. And probably, by the way, there is an update for this, so check it out. But anyway, either way, we can still see all of these strings. And as you can see here, I want to show you one thing probably, which we pass through so over here we can see the type is wide, or in some cases you might see them as Unicode, referred to as Unicode, in some cases as wide. So that means it's using multiple bytes for every single character. So this is also important, by the way, to make sure you search for strings which are using wide characters. If we go to the DOS header, probably the only two important things is the magic value 5A4D, and then probably the offset of where our file address header is located. Okay, and as you can see, it's at 108. If we go to, let's say, the file header, we can see the machine type is 8664, which is an AMD 64 architecture. We can see the 7 sections, similar to what we saw before. This is the value, and this is how it's interpreted, similar to what we saw in Detect It Easy. The size of the optional header, we can see these characteristics. And a good thing about this, by the way, is one thing you can do here is, let's say you want to set it up to 100. As you can see now, this is setting the characteristics of the exe to 100, which is going to now change it to say this is a 32-bit machine. Now, why you might need this? We don't need to do this for 100, but we may need to do this later on, and we'll talk about that when we get to probably to avoid like ASLR and stuff like that. We'll get there in the future. Optional headers, we can see these are the optional headers. We can see, for example, the entry point. Sorry, where is the entry point of our executable? We can see the image base. So this is where the image is going to be loaded into memory, the base of the image. We can see the section alignment in here, which is 1000 in hex, which translates to 4096 in bytes. So each section is going to be aligned to 4096 in memory, and 200 on disk means it's going to be aligned to 512, which is similar to the sector size, and so on and so forth. We won't go over all of these, by the way, because we will be covering as much as we can going through these videos. But for now, we'll try to focus on some details, and then as we go through this series of videos, we'll add more to our investigation. Section headers, again, we can see this is similar to what we had in Detect It Easy. We can see the raw address of these are the section names, by the way, and these are really just names. So this is the name of the section. It's telling you on disk or within the file itself when it's on disk. The address of it is at offset 400. Now that's a relative address, so it's relative to where the image starts or where the beginning starts, and again on disk it's going to be the beginning of the file. This is the raw size, and then we have the virtual address and the virtual size. So the virtual address is relative to the image base. So if the image base is going to be located in address, let's say, just for example, 40,000, then this is 40,000, 40,000, and add that to that. So it's going to be 40,001, 41,000, sorry. And then it's going to be just really like that. So you just add the address, it's a relative address, and the virtual size. And then these are the characteristics about this section, which will kind of define, let's say, the what type of permissions and details does this section have. So for example, as you can see here, by just hovering over it, it's telling you that this is this section has code, it is executable, and it's also readable. So it has read and execute, and it has some code in there. If we hover over this one, as you can see, this is initialized data, and it's only readable because our data is for read-only data, and we can see the same details that we talked about now, which is the raw address of where the section is located. Okay, we can see, and if you, by the way, if you click on this, and then as you can see now, when we follow and click, if we click on it, we can see it's taking us, by the way, to that address. So when we click on this, it's taking us to that address over there, and we'll dig into more details about this later on in future videos. But it's important to know this is the raw address on disk. This is the address when the executable is going to be loaded in memory. If we go to imports, similar to what we saw before, okay, we can see that kernel 32, we are, the nice thing here, we can see the number of functions which are being, let's say, referenced in kernel 32. So we have 104 functions. All of these are the functions or the APIs that are being referenced. We can see user 32, we only have one. Shell 32, we have one. WinInet .dll, we have 5. These are the 5. And then URL monitor we have, or URL mon, sorry, .dll we have one, which is over here. Okay, we'll talk about like all of the other details like the ordinals and the thunks and the hints about that in future videos. And the resources, we can also see the resources over here. This is the only resource we have, which is this one. Okay, and if we go to the content, we can see the content just like we saw previously in Detect It Easy. So that's it for this using this tool. Let's go ahead and look at another tool for this. So you can, if I right click and say okay, we'll just run it from over here. So let's use PE Studio and drag and drop this over here. Now, PE Studio is another great tool for reconnaissance against an executable, and you'll see in a little bit. It's now, by the way, doing some analysis and doing some inquiries online and checking out, pulling a lot of info from this executable. As you can see, it's giving you the hashes, it's telling you the first bytes, whether in text or in hex, the size of the file. You can see the entropy also being calculated. It's telling you the tool is being used to compile or create this executable, which, as you can see in here, is Visual Studio 2015. So as you saw, probably Detect It Easy gave us 2019. Both are good tools, giving us different answers, but kind of it gives us an idea of what's going on. We can see that it's an executable. Later on in the future, when we look at a file, you might see here that this is a DLL, so we need to know how to deal with that. 64-bit, so it's telling you that this is a 64-bit, it's a console, telling you when it's compiled. So these timestamp were pulled from the compiler timestamp, and then there's a debug timestamp and this is pulled from, let's say, some debug sections or directory in there. And we can see other details or metadata which is being pulled from here. Now, if we go to the indicators, which is a really nice thing about Detect It Easy, which kind of tells you at the top over there, it kind of tells you what's the indicator, whether it's from and where it's being pulled from, and then the detail, what is it referring to, and then the level of like how much the level of, let's say severity level probably of this indicator. So we can see that this executable requires administrator. We did see that, by the way, when we were looking in Detect It Easy and PBear, etc. We can see that based on the APIs that the PE Studio analyzed and found within the executable, it is telling you that this executable deals with files. So it's probably doing some file operations, whether creating files, opening files, etc. Execution, so it's probably executing something. Dynamic library, so it's probably also dealing with some libraries in there. We can also see over here, it's maybe doing some diagnostics, reconnaissance. So probably those kind of things are happening. Memory related, so it's probably doing some memory, creating, let's say, allocating some memory or whatever. And again, this is kind of helping you with your analysis on understanding what could this executable be doing. We do not have a definitive answer yet, but this is kind of giving you a really good idea of probably what this executable is doing. Now, if we go to the libraries, as you can see here, these two libraries are flagged. One of them is because it's dealing with the internet, and then the other one is probably because it's dealing with URLs and downloading, probably used to download. And then, so that's why they are flagged. But by the way, that doesn't always mean these are malicious, because at the end, why did Microsoft created them to be used for this type of operation, whether dealing with the internet or downloading files from the internet to be used for whatever purposes for a developer. So it's not always, by the way, that this is bad, but it is a good indicator for us to, hey, wait, you need to check this out because it is using this library, so maybe you need to investigate that. Now, another good thing, by the way, is it's also mapping kind of what it saw on the EXE with the MITRE techniques, with the MITRE attack framework. So it's telling you, for example, that this executable is mapped also to technique 1082, technique 1055, etc. And you can kind of go and Google them and see what are those techniques. One of them is probably for, like, let's say, reconnaissance. One of them is for process injection, etc. So it's really based on its analysis. It was able to kind of map that for you. Again, does that give us a definitive answer that this is probably what's happening? The answer is no, but it is helpful for us to keep an eye out of what are we probably going to be seeing down the line when we look at this executable. Now we can also see the URL that has been pulled, and probably, by the way, when we were looking at the strings, we did see some weird long string, and but it was probably encoded or it was obfuscated, so we couldn't really read it when we were looking at it in let's say as raw data in those executables. But as you can see here, P Studio was able to automatically kind of decode that and give you the full path to this URL. So it seems this executable is referencing an image. We don't know yet what that image is, but at the end we can see that. Other things is the entropy, the executable, and again, these are a lot of other features which are being referenced in here and telling you that these are indicators of probably things that might be suspicious. I would call it like that. Now, DOS header, again, this is how things are displayed, by the way, all displayed in kind of like a table format. So you have the property and then you have the value over here, as you can see over here. If we go to sections, we can see over here it's telling you we have 7 sections. Excuse me. We can see the section. This is because it's like an array. So section 0 is for the first section. Section 1 is for the second section, and so on and so forth. So we can see the name of the section. We can see the SHA-256 of that section. We can also see the entropy for each one of those sections, and so on and so forth. We can see like the raw address. We can see the raw size of the, so this is the size. Over here, we can see the virtual address and all of that details. And down here, we can see the characteristics. So when we look at, for example, the .text section, we can see that this is being highlighted because this is it should be executable, and so on and so forth. Now, if we go to the libraries, we can see these are the libraries which are being pulled. And as you can see here, these were the 2 that had been triggered or were listed in the indicators tab. And as you can see here, these 2 were flagged, and these are it's being categorized as network related. Imports, we can see all of that as well. We can see all of the imports, by the way. So we can see all of these imports, which are the functions. We can also filter them or kind of sort them out. So we can see these are all of the, let's say, APIs which are being triggered and flagged. Like, for example, we can see create process. We can see create remote thread. So, and then we can also see create tool help 32 snapshot. So we might be seeing some searching for process. We can see open process. We can see all of these, and then probably some of it is related to creating processes. Some of them are related to kind of maybe, let's say, doing some injection, process injection, regardless what type of process injection. For now, we don't know yet, but this is all good indicators of what might this executable be doing. Now, as you can see here as well, it's kind of categorizing these for you. So it's telling you this is related to windowing, these are related to synchronization, and these are related to reconnaissance, probably going on. We can see these are related to network, memory related, file related, execution related, and so on and so forth. Also, we can see over here, we can also kind of categorize things based on the technique. So as you can see here, this is for the 1057 for process discovery. We can see T1106 for executions through API, and so on and so forth, by the way. All of this is being kind of pulled for you from Detect It Easy, which is a really great tool to also check out. As you can see here, these are the strings. So let's go there. We can see each string, by the way, where it's being pulled from. So we can see the location. We can see the type of string. Here it's saying ASCII, the size, whether the string is flagged or not. So let's say, for example, filter based on that. We can see all of these strings have been flagged. Okay. If we want to maybe, let's say, sort based on the size, so we could probably do that. And now we can see these are the strings that have the longer size. Over here we have string which is 39 characters long, and so on and so on. And what type of string are we dealing with? And also you can search based on, as you can see, or filter based on, let's say, the section. So it's really giving you a good way to look at tools. And I'm sure if, by the way, probably you purchase the professional license, there are other great features in there, but that's up to you. This is still a great tool to use, even though we might not be using the professional license. If we go to the manifest, it's telling you that it requires administrator in order to run. So this is all great information that we are pulling from the executable by just looking at the headers. We have not run the executable yet. We have not done anything yet. Just by looking at the headers, strings, and the indicators, excuse me, that are available, we are able to kind of have a good idea of probably what this executable is really doing. Okay, so let's go ahead and probably start another tool before we end today's video. I'm gonna pause my recording just to make sure we get okay. So it is here. Before I pause, I'll pause it once I let's say have this analyze a file, because it might take some time to do that, and I don't want to kind of leave you just staring at the tool while it's running. So if we do Capa, by the way, and then just you can put .exe if you want, and then just drag the file over here. Can do this. Okay, no problem. So if we do that and then give the executable, and now if we hit enter, by the way, this is going to be analyzed by Capa, which is a really great tool for analyzing executables. I'm going to pause the video for now until this is finished. Okay, so it seems Capa has finished, by the way. If we scroll all the way up, or maybe if let me do this so we can cover more space. So if we scroll all the way up, by the way, we can see, and this is, by the way, a tool created by the Mandiant team, also the same team who created Flare. Lots of great tools from them, who are part of now, I think, Google. So you can see the hash values were already automatically also pulled for you and calculated for you. The OS Windows format, it's a PE file. Architecture, it's an AMD 64. The path where this executable is, etc. We can then look at the attack tactic. So, and this is from the MITRE framework. So we can see the tactic is defense evasion, discovery, executions, and then under this we can look at the technique which is being used for. So, for example, file and directory permission modification, indicator removal. So there is some timestamp getting and being used in here. So probably this executable is doing some time stamping. So this is very important, by the way, to keep an eye out where that might happen, and we'll see that in future videos. if that is really true. Again, Capa's doing a kind of like a deep analysis on the executable based on all the headers, maybe based on the libraries being there, doing some internal checks on the assembly or disassembly of the code behind it, and then with a lot of signatures based on their history and like of examinations of malware. They probably have hundreds of thousands of probably like databases with similarities that they can kind of based on the similarity say, oh, this file is doing timestamp and whatever. We can see process injection on the discovery side. We can see these are all on the discovery side. It's also nice telling you which technique, the number of the technique as well. Now, if we go down here, we can see the behaviors. So we can see the malware kind of behavior. It has a command and control. So it's using a C2 communication. So it's probably receiving some data, doing some communication using HTTP, creating a request, downloading a URL. So all of this, when we go, before I continue, we can see also some encoding using XOR. So there is some data probably being XOR'd, and we'll see that in the future. Again, when we do some deep dive analysis on the executable itself. Discovery, execution, so installing additional program. So it seems it's installing some additional program. All of this, by the way, was done just by running Capa against the application or this executable. It's creating processes, it's creating threads, it's terminating processes. All of that is being done in there. Now, as you can see here, by the way, this is an old version of Capa. So probably if you want to download the newer version, you can. And it's probably going to give you a different answer. I would recommend, by the way, you download the newer version, and because this comes with the Flare VM, but the team really keeps it updated, because there is, by the way, one thing that the newer version will give you, which I'm not going to spoil it and leave it as a kind of a surprise for you to find out. But all of these are all of the capabilities that this executable is doing. So you can see there is some anti-analysis, there is some timestamping, there is some files being downloaded, there is some encoding happening, there is probably like an embedded PE file, so keep an eye out for that. It seems that this executable might be already loaded with another executable. So there's a lot of things going on in here, which could appear when you're doing further analysis, and there's a lot of other things that you could probably pull up from just looking at the results of Capa. So again, what I would recommend you do, really download the newer version and run it and see. There is one really cool feature. I did this on purpose. I don't want to spoil what this is going to do, but if you run it against this executable, the newer version will tell you an indicator, a really good indicator about, or let's say, it will give you an idea of, hey, this exe is doing this. So I'll leave that for you. Okay, but still, if you just run with this, or if you say, this is enough for me, I think this is really a lot of details that we just pulled from looking at basically just running the tool against the executable. So still a lot of good information in there, but maybe always have a second copy of the tool. Sometimes old tools give you some feature that you are used to, and then sometimes the newer version might have some updated capabilities which might be also useful for your analysis. So always keep an eye out for that, and keep a second copy maybe handy with you. So that brings us, by the way, to the end of this video. I hope you now have a good idea of when we get a file or a suspicious executable, what should I do? Extract the executable, go through a couple of tools, use the tool, by the way, that you want, that you prefer. It's really not about the tool, it's more about like understanding what am I looking for. All of these are great tools. It depends on how you use them, what are you using them for, what are you looking at. And as you can see, some of them will give you results in one way, another might give you the results in another way. So it's up to you, which one do you prefer. It's really a preference. more than this is a tool which is better than that. And some of them have capabilities which others don't, and that's why it's always good to have like experience or learn about the different tools, because then when you get to a point where, oh, I need to do this, but oh, this tool cannot do that, then you can easily shift gears and use another tool and then go from there. So that's it for this video. I hope you were able to learn something out of it. And until we meet again in next videos, thank you so much for your time and have a good day. Bye-bye.